Hello everyone, and welcome to our Chapter 8 study guide. This is going to be page 1. So the directions for the first 3 say that we want to write a ratio of the first measurement to the second measurement. That order is going to matter. Just remember that for ratios, we want them to be in common units, and we want them to be in simplest form. So we're going to use whole numbers for that, but we want them to be in the simplest form possible. So if we want to compare the height of a tree to the width of a tree, the first to the second, that's going to be 14 over 4. Those are both already in feet, so I don't have to do any conversions. 14 over 4 reduces to 7 over 2. So the height to the width, it has a ratio of 7 to 2. Now we're going to look at the length of a canoe versus the length of a stick. Unfortunately, this is mixed units because that's in feet and inches, while this one is only in inches. And so we're going to convert that canoe to completely to inches. So what do I do to do that? We are going to take the 7 feet 4 inches, and we're going to do 7 times 12, because there are 12 inches in every foot. Think about a ruler. And then we're going to add the 4 inches remaining. And so that ends up giving us 88 inches total. And so now I can write a ratio because these are both in inches, and I can compare the length of the canoe to the length of the stick by doing 88 over 8, which reduces to 11 over 1. So my ratio of the length of the canoe to the length of the stick is 11 to 1. All right, now we want to compare the width of the football field to the length of the football field. Thankfully, these are both already in yards, so I'm just going to say 50 to 100 against the first to the second, which reduces to a 1 to 2 ratio. All right, we're doing this again. However, this time it's written from a sentence, and we want to write the correct ratio. The height of a tree is 38 feet tall is the height of a tree, and its shadow is 4 feet 6 inches. We want to write a ratio of the shadow to the tree, so that's going to be green to pink, the way I've color-coded this, green to pink. The height of the tree is 38 feet tall, its shadow is 4 feet. So what we want to do is, that's 4 feet 6 inches, so we want to convert that completely to inches. And so when I do that, I'm going to have to do 4 times 12 plus 6, and I'm going to compare that to 38 times 12. 38 times 12. We are having to convert all of this to inches. And so when I do that, I'm going to do 4 times 12 is 48 plus 6 is 54. So that's going to be 54 to 38 times 12 gives me, double check, 456. And when we reduce that, the shadow to the tree height is going to give me 9 over 76. 9 to 76 or 9 over 76. You can write that either way. That's the shadow compared to the height of the tree. All right, now it says the base of a triangle is 6 inches. So I'm going to highlight that. The base is 6 inches, but the height is only 2 inches. What is the ratio of the base to the height? So blue to pink, of the base to the height. That tells me what to write first. Those are both already in inches, so thankfully I get to go ahead and just, I don't have to do any conversions. I get to go ahead and write my ratio. So we want base to height, so that'd be 6 over 2, 6 to 2, both in inches, which reduces to 3 to 1. You can also write that as a fraction if you want to, 3 over 1. That just tells me that the base is 3 times the amount of the height. Okay. So we could have written this one either way as well. All right, now we're going to solve for the indicated value. The perimeter of a quadrilateral is 112. So if you go around all 4 sides, it should add up to 112, the original 4 sides. But the side lengths are in the ratio of 1 to 3 to 4 to 6. This does not mean that the original sides were 1, 3, 4, and 6, because of course for that perimeter you do 1 plus 3 plus 4 plus 6. That would be 14. That would be 14, which is not obviously the side lengths. And so what this means is that this has been reduced. This ratio has been reduced down to 1 to 3 to 4 to 6. So the original pieces, we have taken the same amount out of each of these sides, these original sides. So what can I do with that value? I can use that to write an equation and say, hey, all of these original pieces, 1x, 3x, 4x, and 6x, should have a total of 112 inches for the perimeter. And then I can combine like terms. And again, I get 14x is equal to 112. So when I divide by 14 on both sides, I'm going to get 8. So that is what x is. That's what I've taken out of each of these pieces. So what were the original pieces? I can go back and plug that in. That's going to be 1 times 8 to 3 times 8 to 4 times 8 to 6 times 8. It wanted all 4 original pieces. So that would be 8 to 24, 32, and 48. That would be the original side lengths. If I ask you for the smallest, you'd say 8. If I ask you for the biggest, you'd say 48. And you can check this by adding up all those numbers, and they would in fact add up to 112. All right. A band director needs to order uniforms for his students. The size ratio for smalls to mediums to larges is 3 to 8 to 4. So it does say small, medium to large. So small is the 3, medium is the 8, and large is the 4. That's the ratio they're in, but there's actually 194 uniforms total. So that means that this has been reduced by the same amount. The 3, the 4, the 3, the 8, and the 4 all had the same thing taken out. They were reduced by the same amounts. So those are my original amounts that I ordered, and I can add those up. I don't know what X is, but I can find out by adding these up to the total. And it says that this band director ordered 195 uniforms. And so 15X, let's see, 15X equals, when I combine like terms, equals 195. And X is equal to 195 divided by 15 should be 13. Yes, okay. And so it wants to know what is the number of mediums. That should be in the middle. So all I have to do, I could plug it in. I could find all the pieces if I wanted to, but I really only have to plug it into this middle piece because that's the amount of mediums is in the middle. So what we're going to do is we're going to do 8 times 13 is that's going to give me a total of 104 mediums. The band director ordered 104 mediums. All right, the measure of supplementary angles are in the ratio of 1 to 4. What is the measure of the smaller angle? And unfortunately, it does not give me a total here. Like on the other problems I've done so far, I had a total of 195, a total perimeter of 112, but this just says supplementary. So you have to think back to chapter 1 and what we said that supplementary angles added up to. It was a pair of angles that added up to 180. So again, I'm going to do like what I've been doing, 1x to 4x, and I know that 1x plus 4x should have a total sum of 180 degrees if they're supplementary. So then 5x equals 180, and so x equals 36. To find the smaller angle, I'm going to do 1 times 36, which is going to be 36 degrees. 36 degrees is the smaller angle. If I wanted to know the larger angle, I would do 4 times 36. And you could check that by adding them up and making sure that they do have a sum of 180 degrees, which they do. All right, the measures of the angles of a triangle. So again, this doesn't give me a total sum, but we know that the measures of the angles of a triangle do have a sum of 180 degrees. And they're in this ratio of 1 to 2 to 3. So 1x to 2x to 3x. We know that that's been reduced because obviously 1 plus 2 plus 3 is not 180. But 1x plus 2x plus 3x is equal to 180. I combine those like terms and I get 6x equals 180. And so x equals, let's see, that is 30. So what are the measures of the original angles? We just go back and plug that in. 1 times 30 to 2 times 30 to 3 times 30. So one angle was 30 degrees, one angle was 60 degrees, and one angle was 90 degrees. So this was a 30, 60, 90 triangle. If I said what's the largest angle, you'd say 90, the medium angle would be 60, and the smallest angle would be 30. All right, number 10 is a little bit tricky. Number 10 is one that a lot of people missed when we first tried this on the assignment because it talks about the perimeter of a rectangle. And we know that a rectangle, just to give you a visual, has 4 sides. And it says that the ratio of the width to the length is 3 to 4. So that's going to put 3x to 4x. Well, we know that perimeter means it goes all the way around the shape, right? It adds up all the side lengths. Well, how many sides should be in a rectangle? It should be 4. So if you're going to work with the 280 number, if you're going to do all 4, I would need to do 3x plus 4x plus, the 3x would be on this side as well, and then the 4x would be on this side as well. And you could add all of those up to 280. But we talked about when we went over this assignment in class, if you wanted to just use the 3x and the 4x, you could set that equal to half the perimeter. Half the perimeter would be 140. So if you wanted to work with 140 here instead, then you could just do 3x plus 4x equals 140. And many of you did that. And so that would be a time saver for you. All right, so let's look at the picture. Let's see the way we've done it, though. We added them all up to 280. So then we would combine like terms, and we'd get 14x equals 280. So x is going to be equal to 20. it wants to know what is the length of the rectangle. So it was in the ratio of width to length, so we're going to plug it into the 4 piece. So 4 times 20, that should be equal to 80. What are our units? 80 centimeters. 80 centimeters is going to be our length. If we wanted to find our width, we'd plug it into the 3. We'd do 3 times 20, it would be 60. Okay? All right. Next problem says you make a scale drawing of a tree using the scale 5 inches equals 27 feet. So you see this a lot on a map. 5 inches represents 27 feet. So it says if the tree is actually 67 feet tall, how tall is the scale drawing? So when I go to create a proportion here, I want to put the feet across from the feet here. So that is in feet. It wants to know, well, how many inches is that? So we're going to put an X there. We don't know how tall is the scale drawing of the tree. So now we're just going to cross multiply. And so you're going to type in 5 times 67.5. And you are going to get 337.5. Whenever you do that, you multiply those together. And that is going to be equal to 27x. And so you divide by 27 on both sides. And so that would be 12.5. What are my units? My units are going to be in inches over here as well. So that scale drawing would be 12.5 inches tall. All right, Lance the alien is 5 feet long with an 8-foot shadow. If a tree's shadow is 32 feet long, what is the height of the tree? And so what we're going to do is we're going to set up a proportion here. These are both already in feet. Okay. And so if a tree's shadow is 32 feet long, what is the height of the tree? So 5 feet to 8 feet is going to be proportional to the 32 feet long. What is the height of the tree? So we're comparing the height. And so that's going to be x over 32. Because this was length, this was height, the way we wrote the original ratio. And so we had 32 feet long. Let me make sure I set this up right. Hold on one second, guys. Oh, nope. Okay, here we go. Let me highlight it. This always helps me out. 5 feet long to the 8-foot shadow. The 8-foot shadow. Okay, so that's going to be his length to his shadow. So it's not his height, it's his shadow. Shadow. Okay, so then it says that if the tree's shadow is 32 feet long, so the shadow is 32 feet long. Yeah, so I did that right. So let's put the 32 here. What is the height of the tree? And so what we're going to do is we're going to cross multiply here. And we're going to end up getting that 160 equals 8x. So x is going to be equal to 20 feet. What is the height of the tree? So when it says 5 feet long, we really should have said 5 feet tall. I think that's what's throwing me off here. Lance the alien is 5 feet tall, so we're not going to fill in the word length. I need to rewrite how this question is written. Lance the alien is 5 feet tall with an 8-foot shadow. So we're doing his height to his shadow. And so if the tree's shadow is 32 feet long, what is the height of the tree? So we're doing his height to the length of his shadow. So that is going to be 20. Okay, solve the proportion. So again, y'all have gotten so good at this unit, you're just going to cross multiply. So we're going to cross multiply, and our cross products we're going to set equal. So that would be 52x equals 13 times 4, which is 52. We divide by 52 on both sides, and we get that x is 1. And you can check this. If you go back and you put a 1 right here, 1/4 is the same fraction as 13 over 52. If you use your calculator to reduce 13 over 52, you're going to get 1/4 as well. Okay, so again, we're just going to keep cross multiplying, but on this problem, we're going to have two variables on a variable on each side, I should say, not two different variables, but just a variable on each side. And so what happens when I cross multiply is I like to put this 2x plus 1 in parentheses because that reminds me that I need to distribute the 16 both to the 2x and to the 1. And so I'm going to distribute, and I get 40x equals 32x plus 16. I get 8x equals 16, and x equals 2. Again, you could go back and check this by plugging this in. This would be 2 over, I believe that's 2 times 2 is 4 plus 1 is 5. 2/5 is going to be the same thing as 16 over 40. You could verify that in your calculator. Okay, so let's do that again. This problem already has the parentheses for me, so I'm going to be doing 8 times x plus 1, distributing that out, and then 7 times the 2x plus 10. So just don't forget to distribute. Minus 10. So we're just distributing the 8 here and then the 7 here. So 8x plus 8 equals 14x minus 70. And so we're going to get our variables on the same side. I know that y'all know how to do this, and if you don't, just come see me. I'm happy to help you. And so what we're going to end up doing is we take 78 and we divide it by 6, and when we do that, we get 13. We get 13. Okay? All right, last little set. We are given, so this is important. It's kind of like the very first step of our proofs. It is given to us that PRQ, that triangle, PRQ, is similar to DEF. So it's not saying that they're congruent, it's saying that they're similar, which means that all of their angles are the same, but their sides are proportional to each other. So the very first thing I'm going to do whenever it says that two triangles are similar, I copy the angles from the left triangle to the triangle on the right, and I copy the angles from the right triangle to the triangle on the left. So because it says, if you couldn't tell what goes together, because Q is 89, I know that F is also going to be 89, so it tells you where to put it, 89 degrees. Okay, so those are going to be congruent to each other. And then you've got the 35 degrees for E. So that means that R is also going to be 35 degrees. And then last but not least, we can find this final angle using the third angles theorem. So D and P are going to be the same angle. That gives us 56 degrees. So let me mark that the same. So 56 will be this last one, 56 degrees for P and 56 degrees for D. So that actually allows me to go ahead and fill in some of these pieces. What is the measure of angle D? The measure of angle D is 56 degrees. What is the measure of angle P? Angle P is also 56 degrees. And what is the measure of angle R? Angle R is also going to be 35 degrees because we got that from the other triangle. So now we want to find the scale factor of PRQ to DEF. So remember, we're going to do new over old for that. So the only pieces that we have corresponding so far that we know both of is the 24 and the 20. Those are the two shortest ones, you can tell by looking at it, but if you wanted to tell mathematically, if it's not drawn to scale, check that DF is the first and last, PQ is the first and last. So I know that those two blue pieces go together. So in other words, what I can do is I can say, okay, well, that's going to be 24 over 20. So I know that this shape is getting bigger. So I divide both of those by 4 and I reduce this. When I divide by 4, you would get 6/5. 6/5. So if I ask you for the reverse, DEF to PRQ, you would get 5/6. Okay? All right, so now we want to find side length DE. So I'm going to color code this. DE is this piece right here. It's X. Who corresponds to DE? That's the first two letters. That'd be PR. So what I can do is I can create a proportion to solve, and I can say, okay, I did 24 over 20 earlier. Those are the ones that were known. So if I did 24 over 20, that should be equal to X over 40. So I'm going to cross multiply, and when I do that, I end up getting X equals 48. That did get bigger as I anticipated, and so DE equals 48. Okay? Even though it's not drawn that way, this shape is getting larger. Okay, so it's not necessarily drawn to scale. So I know that Y should be larger than the 36 as well. And so I'm going to use my known pieces. I'm going to do 24 over 20 equals, I went right over left when I went 24 over 20, so I'm going to do right over left again, Y over 36. I cross multiply and I solve as I did earlier, and I get 43.2. 43.2. I believe that's what it would round to. Let's see, let me make sure. So 36 times 24 divided by 20. Nope, it's exactly 43.2, so I could say that's what it's equal to, not what it rounds to. All right, I'm going to be posting part 2, page 2 in a little bit.